Hey guys, welcome back to Math with Saba. Before we start, don't forget to press the like button and subscribe to my channel. Today we're going to learn all about quadratic functions and graphs. First of all, let's take a look at the general form of a quadratic function. Y is equal to ax to the power of 2 plus bx plus c. This is the general form of a quadratic function. Fx here, it means function of x. This is a fancy way of saying y. So whenever you see fx, it means y. The graph of a quadratic function is something like this. We call it a parabola. It can be upward, it can be downward. Three factors that are in red circles here are A, B, and C. Each of these factors shows us something about the graph of a quadratic function. First of all, let's talk about A. When A is greater than 0, it means our parabola is concaved up. It is upward. And when a is less than 0, it means our parabola concaved down. And a can never be 0. Because if it was 0, our quadratic function will turn into a linear function, because no more we have the term of x to the power of 2. And b helps us to find the symmetry line of our graph. Axis of symmetry has an equation of x equal to negative b over 2a. With this formula, we can find out where is the symmetry line of our parabola. It is obvious that this is a vertical line because x equals something always was an equation of a vertical line. And C represents the y-intercept of our quadratic graph. Here you can see C for the blue one, the dark blue one here is shown. It is passed through the origin of the coordinated system, so C will be 0 here. And here you can see another graph of a quadratic function, and C or y-intercept of this graph is shown here. This one is upward, so the a must be greater than 0. This one is downward, so a must be less than 0. Another thing to know about a quadratic function is the vertex of a function. When a quadratic graph is concaved up, it means it has a minimum amount. And when it's concave down, it has a maximum amount. To find the minimum and maximum, we have to find the vertex of our quadratic function. Vertex of a quadratic function is a point that is located on the symmetry line. It has a coordinate of x and a coordinate of y. As it is located on the symmetry line, so its x will be the same as the equation of the symmetry line, which is negative b over 2a. For calculating the y, we have to know there are two ways to calculate the y coordinate of the vertex. One of these two ways is negative delta over 4a. We're going to talk more about the amount of delta in the next video. And the other one is f of negative b over 2a. It means the y amount when we substitute the amount of x with negative b over 2a. We're gonna do all the calculations in this example. Okay. Here first of all we have to figure out if it is a quadratic function. We have x to the power of 2, so it is a quadratic function. First of all, let's identify a, b, and c. The coefficient of x to the power of 2 is a. the coefficient of x is b, and the constant term is c. So a is less than 0 because it is -3. So it's less than 0. So our quadratic function is concave down. So it's going to have a maximum. And c is -4. This is our y-intercept. And the axis of symmetry was x is equal to -b/2a, which is b is +1, so -1/2 times -3. It's 1/6. This is the equation of the symmetry line. I'm gonna draw an approximate shape of this figure. It is downward. The y-intercept is -4 here. And the symmetry line is here, almost here. So our quadratic function will be something like this. We don't know anything about its zeros or anything else, but we can approximately say that this is something like this. To find out the vertex of this function, we know the x-coordinate of the vertex is 1/6. To find the y-coordinate, we have to substitute 1/6 in this equation. How? Like this. F of 1/6 will be -3 1/6 to the power of 2 plus 1/6 minus 4. Okay, -3/36 plus 1/6 minus 4. Let's make the denominators the same. What do we have here? 36, 36. We'll get to -3/36 plus 6/36 minus, let's multiply 4 by 36. It's 144. And our answer will be -141/36. This is the coordinates of the vertex of our quadratic function. So here is what we know. Please keep watching the next video to know all about quadratic functions. Thank you.